Okay, good morning, everyone. Welcome to our day. I'm going to talk about data wrangling. I was trying to think about what I would do at a visualization conference, and I was thinking my strength at data visualization is preparing the data for the visualization. And as you can already see as a hint in the background of this image, I'm going to try to brainwash you all into doing more of your work inside rectangles than maybe you would, that you could embrace the data frame even more. There used to be this Twitter account called Big Data Borat, which has sadly gone quite silent, but he had a take on this lament that we spend 80% of our time preparing data and the other 20% complaining about the 80% of our time that we spend preparing data. And my advice on this front is that you actually just admit this is true and get better at wrangling data. So that's actually why I've ended up teaching so much about data wrangling, is because I would not teach so much about it and I would let students loose on projects and they would come up with super interesting ideas and data sets. And it was always the data wrangling stage where the wheels came off the wagon and people got stuck. And so I feel like I have a lot of people in my life who treat their data set like this horse that they're going to whisper to, and they don't want to upset it. And then we find ourselves, like, they come to me asking how, I'm pretty sure I need to write a double nested loop, and in the first layer I want to programmatically construct object names and then write them into the global environment. And then inside that, I want to loop over something and then write onto a ggplot. And like all of this is just fighting the tool over and over again. And I used to get sucked into these puzzles because they can be slightly fun R puzzles. But then now I've just refused to do this. And I'm like, we need to look at your data set, because if you're fighting the tool, it probably means you could do some more data wrangling and then have everything just flow much more easily. So I think it should feel more like this, where you take charge of the data because you're in charge and you don't need to leave it pristine in the form that you found it. It's quite often the case that gathering a bunch of disparate objects lying around your workspace is a great idea, and reshaping it in a certain way is a great idea. And so the meta habit that I'll advocate, and it took me more years than I'd care to admit to really get this, is if you can put something in a data frame, you should seriously consider putting it in a data frame and make that your default receptacle. Because sometimes I would have things where, like, maybe I could keep it as a matrix because it was all numeric. And I would think, oh, I'm going to save memory, or who knows what I was thinking, or I'm going to that simpler is better. And matrix must be simpler than data frame. But I've definitely come around to the fact that even if you can keep it in something else, you should seriously consider keeping it in a data frame, because we have so much tooling and workflows built around data frames that you get to enjoy all of that either way. But I am going to talk about sort of a second level meta habit, which is if you're going to keep everything in a data frame, not everything can naturally be solved with atomic vectors and simple variables. Like every now and then you're going to have to be willing to pull a variable out and do remedial work on it, which is not what I'm talking about today. And then every now and then you're going to have to be willing to go to a list because you need to do something a bit more complicated. And so you have to have a strategy for tolerating that uncomfortable state temporarily, getting your work done, maybe keeping it in the data frame, or like getting back to a simple data frame as quickly as possible. So again, in my teaching, I feel like this is an oversimplification of what data analysis feels like, but we kind of go through a stage of cleaning and wrangling. Eventually, we get to what we consider the real work, which is the descriptive statistics and the inferential statistics. But you know it like never actually goes that way, right? You're moving forward and then you're trying to do some descriptive statistics or inference and you realize the data's in a really unfavorable form, so you go back and you change your cleaning and your data shaping, and then you make another pass through. And something that I noticed, again, a lot in teaching is there's this perverse thing where I think the stuff that comes first and the stuff that seems the least like rocket science is actually the most demanding of your programming skill. And so I think your knowledge of R's data structures and your facility with them is taxed the most at the beginning of a project when you're trying to bring everything in. And then usually by the time you get to descriptive statistics and inferential statistics, you might be thinking harder about statistics and models, but it actually ends up meaning, I think, that a lot of the R work is not as difficult. There's a lot of less choice involved, I'll put it that way. And so if you can use tools that shave off some of this difficulty in the top, you can hopefully spend less than 80% of your time in that part of the project. And so to make an analogy to statistics, when people came to me in a consulting capacity, like the things that would chew up the most time and brain space were where there was no experimental design or really poor experimental design, and you have to compensate with that with a much more complicated analysis. And I think the analog in data analysis is that if you can find the right data model, your analysis tends to go much more smoothly, so you can simplify your life at the front end. So the package that I'm basically just doing an ad for this package is one way to describe my talk. I cannot roll my R's, I'm just gonna call it purr. So this is not my package. Hadley Wickham and Lionel Henry are the two main authors of it. And even though I won't really get to show it in context, in this format, it plays really nicely with some other packages here, in particular dplyr, tidyr, tibble, and the broom package from David Robinson, who you'll hear from later. So I'm going to show you some of the cool things you can do with purr that will help you do more things in a rectangular way than you think. And these are just some links that I'm including mostly so that they're in the slides. I made myself teach this stuff this year, and I've gotten sufficiently uninhibited about putting unpolished things on the web that I dumped my lessons up in this purr tutorial, and I got really tired of making these incredibly boring lists called foo and just putting random stuff inside of them. So I also started to make a package of examples that you won't die of boredom looking at them, called recursive, and you'll see a few of those data sets here. And you'll see by the end that I am like the best at Lego minifigure portraits, and so I also put all those photos up. So the inspiration for me, this is a set of photos that Hadley took, I guess, in a hotel room of the kind of pepper shaker you might encounter in a kitchen where clearly no one ever cooks. And, but it has been used to describe the difference between indexing into a list or a data frame with single square brackets versus double square brackets, which in R, this means like if X is your object, list or data frame, if you ask for the ith element with single square brackets, you get a list or a data frame back, but with one element. So you still have this pepper shaker structure, it just has one pepper packet. And if you do it with two square brackets, you get the naked object itself, like the actual pepper packet. This is kind of important to the talk, but not terribly important, but it's more that I wanted to put up. I have tried to explain that to people in words for like 15 years, but this set of photos made so many light bulbs go on in my students' head that I was like, okay, little physical objects are the key to explaining some of these things that are a bit abstract. And then I've also been enjoying the dark existential humor of Lego grad student. So if you're thinking about leaving or entering grad school, I do not advise that you go to this account, but otherwise, I think you should. So those two things combined in my head, also with this obsession I have with making things rectangular, and the fact that I have like a metric ton of Lego in my basement, and I was like, I'm gonna make little Lego sculptures that depict some of these data structures I'm trying to convince people to use, and then, of course, I get to photograph them over time and do things to them and show some of the operations that are especially fruitful with them. So to start in a familiar place, we have our, your basic garden variety R object is an atomic vector. It might be of length 1, but it always has the capacity to be a vector. And we have basic flavors of our objects, some of which are here: logical, factor, numeric. So if you have a bunch of these vectors and they're somehow related to each other, and they happen to be the same length in particular, that's an obvious case of like you should put this stuff together in a data frame. But the thing to remember is the vectors that you're putting in a data frame, they don't have to be atomic vectors. They can be a general vector, and the more common term you hear for that in R is a list. So you could have a list in a data frame if you're willing to tolerate the discomfort. So that's what I'm going to try to talk you into. So what would that look like in Lego? So we have a 2-column data frame here, and the first column, the single 1x1 whites, is just some plain vanilla, literally I guess, atomic vector in R. And then this second column, the one that makes you feel slightly nauseous, is the list column. And so I've made them all green to indicate something that's often true in real life, which is that you often have sort of homogeneous lists here. So they're not like a random motley assortment of stuff. They have something in common. So in this case, I'm trying to convey that maybe they're all like little character vectors. And they have different strings inside, but they're all character vectors, and they might be of different length. But there's a lot of operations you can do on them that make sense for each object because they have a lot in common in terms of what sort of flavored object they are. So to get to some of these examples that I was talking about that won't kill you with boredom, I decided to look at this. There is an API of ice and fire. God bless these people. And so there's endpoints for characters, books, and houses from the Song of Ice and Fire. So you can hit these endpoints and get data on characters, an example. So here's what happens if I ask for the information from this API for Daenerys Targaryen, who, if you don't watch this or read this, she is the mother of dragons. And so this is the kind of information you'll get back. This is still just showing you the JSON, but this is where a lot of your lists will come from in real life. But I'll just focus on, maybe you have a complicated list coming back from some API, and you don't care about all of it, but you'd like to organize excerpts of this data for yourself in a data frame. So in particular, what if we wanted to organize the names of these characters and their titles? So I think the natural way to organize that is 1 character per row, because that's probably going to be my natural unit of iteration. But the titles are a vector. Like Daenerys has 5 titles, and there are other characters who have 0 or 1 or 2. So it's going to be just like this example I showed you, where I need to tolerate having the titles in a list column, but that allows me to have 1 row per character and do all sorts of normal things that I like to do with a data frame, where the row is this natural unit of analysis. And so you'll see that Daenerys shows up there. You know, her name is there as a string in that very simple character vector, and then her character vector of 5 titles is 1 element of that list column. Here's another way to look at this list, if you're in our studio at least, is this the view, capital V, view, which is nice because you get to see the beginning of the data in each of these things. But one of the awkward aspects of having lists is inspecting them, as you'll see. So why would you do this to yourself? Like, why would you invite lists into your life? And so I think there's 3 main ways it feels like they come to me and I have no choice about it. Now I actually go out of my way to do this, but even before that, if you do string processing, there's a lot of regular expression work you do that will naturally give you character vectors of different length packaged as a list. And you're forced to deal with that at least for a while until you can simplify things. Also, APIs love to send you back information as JSON or XML, which again, you most naturally bring into R as a list and then like chisel away at making it into the data frame you really want. And then even when you're purely operating in R with a regular data frame, as soon as you want to do some operation for every level of a factor, you get yourself into some sort of split, apply, combine workflow that often suggests you should have a list somewhere along the way. But then why would you stick the list in a data frame? I think that's the more controversial suggestion, but I think it's all the usual reasons that if you have different vectors lying around and you let them free range in your workspace, it's very easy to subset one or change the order of one and forget to do that to all the rest of them, so that locking them into this grid together helps you keep them in sync and move them around as a unit. And you probably have an existing toolkit for this. I'm certainly a dplyr person. And so if you can tolerate the list in the column, you get to use all your usual filter, select, arrange, group by, and that list will come along for the ride. And the other thing that's occurred to me lately is if you keep things in a data frame, it forces this Vegas principle on you a bit, which if you're operating on a data frame, especially in a pipeline, right, you're just piping the data frame to the next manipulation, it's semi-hard to bring external information in. You can do it, because you can join things in, but it's a little hard. Like, it's certainly easier to just keep operating on stuff in the data frame, so you're encouraged to get all the information in the data frame and then work on it. And then it's extremely hard to write to any object other than that data frame. Like, people do all sorts of gymnastics or use this T operator. And I think this is great because it forces you to just sort of work on that data frame and then kind of break character a bit if you really want to go start writing into other objects and then come back to the data frame. So I think the discipline enforced by that creates scripts that are less prone to being buggy, I think. So if I've convinced you to have a list column, what are you going to do with it? This is like a GIF that I tweeted a year ago because I decided I was like, so help me God, I'm going to get good at this stuff because I was not very good at it. And I would feel like I would finally make the list column. I was just having a discussion with Adam, and then you're like, there's all this information I want in there, but like, I can't get at it. And it's very frustrating. So I think there's 4 key skills to get out of your list column predicament. So you have to know how to inspect this thing. I think that's stage 1, is like, once you've made it, making sure you understand it. And then you need to be able to query, so pull information back out of it, modify it, it's a little more sophisticated, and then the really glorious thing is you're usually trying to simplify it and get rid of the list column and back to like a simple vector, a simple data frame. So on the inspection front, those indexing tricks that I briefly went over with the pepper shaker photos do turn out to be kind of important, primitive but important, at just pulling out little bits of your list so that you can get to know it. The view command in RStudio is handy. Good old stir is very handy, but you need to work the max level and listlen arguments so that you don't fill your screen. And then I also want to give a plug for the list viewer package from Kent, who you'll hear from next, who is an HTML widget that wraps a very nice interactive viewer for nested lists, and you can click on little triangles and things drop down. And so I think if you attack the inspection problem from all sides, you can actually figure out what's in there. And then these last 3 meta skills to make you comfortable with lists, it turns out they all boil down to using the same set of functions, just maybe in increasingly sophisticated ways. And this is the ad for purr. So the purr package, for me, the core function is a function called map. And map basically is lapply, if you use lapply at all, but with some sort of nicer syntax available to you. So I'm just going to talk about map, and especially it's the anchor to a larger set of map variants that will eventually be handy to you. And so what map does is it's an iterative machine, but it allows you to iterate and to express your iteration in terms of R objects instead of you writing out the for I goes from whatever to whatever logic yourself. So its primary argument, .x, is a vector, usually a list, but it can just a vector. Second argument is a function, and what it's going to do for you is it's going to visit every element of x, apply that function, and it's going to return the results like so. And I'm particularly being vague about that, but entry level, it'll just return another vector or list back to you. So this is where we go out in a blaze of glory with the Lego minifigures. So I want my primary list. I want you to think of these 5 minifigures as a list you need to operate on. They are cute minifigures, but they could be fitted models. They could be data frames. They could be any sort of unit of iteration. They could be bootstrap samples that you need to iterate over. And so it's a homogeneous list, right? They're all minifigures. We're going to be able to do common things to them, but they are each individual minifigures, so we'll get different data back from them. So the first application of map I'll show you is, I didn't show you the code for Intenate, but I think you can probably imagine what it does. So the first sort of entry-level mapping is going to do the same thing to every object. So in this case, I'm plopping this. It took me so long to find 5 of these that had a gray base. Like, they come in many different colors. And we'll apply this uniformly across the minis. So let's go back to the bald minis. One of the nice things about purr that works in all the map variants is there's a really concise syntax for pulling out pieces of your lists by name or by position. So you can also say, like, I just want the pants. So this is very handy. I'll show you real examples with the ice and fire data in a moment, where you just want to pull out the names or something. You don't really want to understand the entire complicated JSON that came back from the API, but there's like that one piece of information that you want. And then sometimes you have 2 lists, and you need to iterate over them in parallel. So there's a version of map called map2, which does what you might expect, and it has 2 primary arguments, x and y, and then the function f. So let's imagine I have my list of minis, and I have a vector of hair, and I might say map2, minis are x, the hair is y, and I will inherit the minis and get their baldness covered with something other than the antennae. Given that they have hair, I could say, let's take my minis, let's take a vector of weapons, and I will arm them. Okay? And so you can build up these pipelines very much like dplyr, and this can be happening inside a data frame, although I won't get to that today. But again, like, you could imagine, you start with the data frame, you split it by some factor, you fit models, and then you start doing things to those models or pulling facts out of those models. So I'm illustrating this with some sort of silly operations, but hopefully you can see that it's sort of a generic stand-in for operations you might want to do on, like, relatively complicated objects, but they have a predictable structure. And now we're going to move more into modify and simplify. So what if you have more than 2 vectors you need to iterate over? We don't have map 3, 4, 5, 6, 7, 8. There's just, you switch to something called PMap, which is you have a list or a data frame of vectors that you want to iterate over, and map will work on each row. So imagine I have a data frame holding a column of pants, a column of torsos, and a column of heads. Maybe this is where the minis came from in the first place. And I have an embody function that will insert the pants into the torso, and then that little apparatus into the head. So you can scale that up over all the minis with PMap. But so I've used PMap to do, like, to spam people. Like, I have used this. I'll have a data frame of people in my course. I'll have, like, email addresses, and then subject, body, blah, blah, blah. And then what I'm doing inside PMap is I'm hitting the Gmail interface, and I just march through my entire class spawning these emails. But so you can use this whenever you have maybe a relatively complicated task, but all the inputs can be kept in some sort of matrix. And the inverse of PMap, where you take a data frame and in this case glue them all together, is mapdf. So this is an example of one of those. For every element of x, apply f, and give everything back to me like so. So df here is the like so. And so you could start with minis and say, please go in there and get me the pants, the torso, and the head, and split it all back out again into a nice, easy to manipulate data frame. So I'll now show you slightly more serious examples that actually have real code. These run using the Game of Thrones data. So an example, again, of this querying and that uses this really nice shortcut that purr has is we can go into that sort of unfriendly nested list of the Game of Thrones characters and just ask for everyone's name. But if you realize those are all just strings, instead of having a list with length 1 character vectors, I'd rather just have one character vector. This is an example of this larger family of functions that are all based on map. This will give you back all the information you asked for, but as a character vector. So this is another example of, for every element of x, please do f, and give it to me like so, as a character vector. And here's the companion, like so, which is please go in there and get name, culture, gender, and when this character was born, and give it to me back as a data frame. So this is, even though you might not think of purr as a data frame related package because it's very list focused, it allows you to tolerate lists and data frames and to get back to simple data frames very quickly once you've done what you needed to do. So here's another example. I can take the Game of Thrones characters. I can go in there and get everyone's name and get a nice clean character vector. I can go in there and get everyone's houses, like who they're allied to, which again, unfortunately, some of these characters allied with multiple houses. So now I have this list column like that original photo I showed you. But this is an example of now I can filter just like I would in a normal data frame, only keeping the meta rows where the character has more than one allegiance, and then I can unnest this to explode it back into a simple data frame. And so there's just a bunch of tools you can use, especially for borrowing or using things in dplyr and tidyr, that if you're willing to tolerate these list columns, you can keep really disparate information there and then quickly flee back to the more familiar territory of a regular data frame. So I will leave it there with one of my creepier minifigures. And I think I have time for a couple of questions. OK, thanks. Yeah. I think they're neither incompatible nor especially compatible. There's nothing special. There's no special treatment of them, but nor is there any special treatment of anything else. So I think if you want to nest data tables in a list column, I don't see why it wouldn't work. But operating on them is very different, so I think you'd have to fiddle with it, see what happens. Yeah. All right, thank you again. I'll let Kent set up. Where'd you go? There you are.